Hey guys, hello everyone, and welcome to the channel. So let's talk about the physical chemistry questions which were remaining in the previous video. So in case you have not watched that, let me know. Let me tell you guys that I have been solving questions from the physical chemistry portion, that is section C of your CSIR-NET exam, which held on 15th December 2019, and I have already solved 10 questions in the previous part of the video. Okay, so if you have not watched that video, I will recommend you to watch that because many of the questions have been already covered over there. Rest of the questions which were remaining, I am going to cover in this particular video, right? So let's go towards the question. And yeah, if you have not subscribed to the channel yet, do subscribe to it. And if you have any doubt, you want to ask anything, you can drop that in the comment sections below. All right, let's move on to the question. All right, so here is the question, which says that the X-ray of 173 picometer wavelength are reflected by 111 plane of the cubic primitive crystal at theta is equals to 30 degrees. Okay, the unit cell length in picometer is closest to. So they have given you the value of Miller indices, that is H, K, and L. The values are 1, 1, and 1. And they have also given you the value of lambda, that is 173 picometer, that is the wavelength of the X-ray which is being used, and also they have used theta. Theta is 30 degrees. Now what you have to use is we have to use Bragg's equation, that is 2d sine theta is equals to n lambda. Now using that we can just solve this to calculate a unit cell, okay, unit cell length. So let's do that. For that we'll first of all calculate d. Okay, so this will be like this 2d, and it will be sine 30 degree. It will be equal to, since it is not given that what reflection they are talking about, first order, second order, so we'll take it as first order. And lambda is given 173, so sine theta is 1 by sine 30 is 1 by 2, so it will be 2 into d into 1 by 2, and that will be 173 picometer. So basically your d will come out to be 173 picometer. Okay, so that's coming out to be the value of d. Now we know that d is equals to, for cubic unit cell, our value of d is given by a upon under root h square plus k square plus l square. Now this h, k, and l is basically nothing but these are the values of your Miller indices. Now you put your d value of d, so it is 173, and a is what you have to calculate, under root 1 square plus 1 square plus 1 square, so that will come out to be under root 3. So basically a will be equal to like 173 multiplied by root 3. Now there is a trick to solve this. Okay, you can get correct answer by multiplying, also by putting the value of root 3 as 1.732, then multiplying it and then getting it. So that is one of the trivial way, but I will tell you one shortcut trick, or how you can manipulate the methods to get your answer. Okay, see, what you can write down is 173, you can write down like 1.73 into 100, right? I have just splitted this as it is, and into it will be root 3. Now this 1.73 is the value of root 3, right? So I can just put here root 3 into 100 and into root 3. Now this root 3 and this root 3 will get multiplied and it will become 3, and 100 is already here, so 3 into 100, the answer will come out to be 300. Okay, so the overall answer will be 300, so that is going to be your option number 2. So that's how you can just use smartly, like you can just be a little bit smart enough to manipulate the mathematical calculations and get the exact answer quite easily without being laborious over there, right? Now let's move on to the next question then. So this question says that the molar residual entropy of solid OCS would be closest to. So how to do this particular question? First of all, we should know that what is OCS and how its structure will be. So OCS is nothing but O double bond C double bond S. Okay, so this is one of the way how it is going to be. Now the molar residual entropy is basically given by this particular formula, that is delta S residual is equals to R ln W, okay, where W is nothing but number of complexions or the number of arrangements, right? So that's what W is. Now how to find out the number of arrangement for this? So for that you have to consider that how this particular like this particular group in the solid form is going to be arranged. Okay, so what are the ways in which this particular group is going to have, like what are the different arrangements which it can have? So either it will be like OCS binding to the other species through sulfur side, or it can be like this, right, S double bond C double bond O, so binding through the oxygen side. Since it's a ambient ligand, so it can bind from two different sides, right? So that's why there are two basic arrangements which can happen for this. So the number of arrangements you have to take over here is 2. Now let's put it over here. So it will be R is given, not given to us, but since we are doing it in joules per Kelvin, so R will be 8.314. Ln I am converting in a log base 10, so that will be 2.30303, and then it will be log, and this will be log 2. Now since we have done a lot of like electrochemistry questions, we know that 2.303 and log 2, basically this is not electrochemistry, but this is where you have done in your first order kinetics, right? In the half lifetime and all, you might get this particular thing while doing the calculations. So the value of this particular part will be 0.693. So you will get 8.314 multiplied by 0.693. So what is going to be the answer? You just multiply it and you will get an answer approximately around 5.8. So that is going to be the correct answer for this particular question. Now how to analyze this is basically like how to approach the answer. Obviously answer is not going to be 0 because you have some numbers, so that is not going to be 0. And since you are multiplying it with a smaller number than 1, so the value will not be greater than 8.3. So it cannot be 8.7 either, right? So that option and this option get cancelled out. So now since you are multiplying it little bit more than the half of it, so half of 8 is 4, so you are multiplying it with a number which is greater than half, that is 0.5. It is greater than 0.5, right? So whatever answer you will get will be greater than 4 also. So greater than 4 answer is only one option, that is 5.8. So this is also one of the way how you can approach towards the answer, or you can simply multiply and go over there. Alright, let's talk about the next question then. Okay, so the next question over here, it says that the 1 mole of perfect monoatomic gas is put through a cycle shown in the figure. The total work done during the cycle is, okay, so this is the cyclic process which is given to you, and they're asking that what is the total work done. So we have to analyze the whole cycle, the processes, and then we have to tell that what will be the work done. So let's try to do this. Okay, so for the first process, that is AB, okay, AB, when you're talking about AB line, what is happening over here? The volume is increasing from 2.3, it is increasing to 4.6, so it's an expansion, right? And since the pressure is constant, because we are doing pressure per bar, and we are doing volumes in liters, okay, so we have taken pressure in bar and volume in liter. So that's what we have taken on the two axes. So this particular process is isobaric, it's isobaric expansion, okay, that's what I can say right now. So the work done, WAB, will be given by minus P delta V, okay. So if I substitute the value of pressure over here is 2, okay, so I'm going to put 2, okay, with a negative sign because I have minus also, so minus 2.0, I'll multiply it by delta V, means change in the volume, so that is 46.48 minus 23.24. So if you just subtract this, so this is what you are going to get as WAB, okay. So let's keep it as it is. Let's talk about the next one, which will be BC, process BC, okay. So now in the process B to C, if you look upon over here, so fine, let's do it. So BC, okay. So when you're doing from this particular point, that is point B, and particular point C, here what you can see that the pressure over here is nothing but the pressure over here is 2.0 and the pressure over here is 1.0, okay, whereas the volume over here is 46.48 and here the volume is 92.96, okay, that's what the values we have. So for the process BC, if I do it at point B, okay, at point B, what I have, pressure is 2.0, volume is given to me as 46.48, and at point C I am having pressure as 1 bar and volume as 92.96. So what you can see over here is if you multiply these two terms PV of this you are going to get what what you multiply with these two and get. Okay, so twice of this is 92.96. So that means what, that P1 V1 is equals to P2 V2. Okay, now this is what you can attain from the values. You have to analyze the values, and then is what you are going to get over it. So what it is telling you, that this particular process is nothing but it's a isothermal process. Okay, it's a isothermal process because Boyle's law is being followed here. Okay, because Boyle's law is being followed here. Boyle's law is being only followed in the isothermal process. So this is isothermal process. So work done in this process, WBC, will be taken by this particular formula, that is minus nRT, and will be having ln V2 by V1. Okay, now we don't know T, right? We don't know the temperature over here. So what to do then? So we have to use ideal gas equation in order to do, because it says that it's a perfect monoatomic gas. So we'll use the ideal gas equation, that is PV is equals to nRT, to find out the value of temperature. So the temperature is going to be PV upon nR. So let's do it. So pressure is, you can do it at any point. Okay, you can do this particular thing at any point because the temperature is constant overall. So you can do either at point C or at point B. I'm doing it at point C. So at point C my pressure is 1, the volume is 92.96, and the number of moles is taken to be 1 mole as per the given question, and the value of R, we have to express the value of R in bars. Okay, and in liters. So in bars and liters, the value of R is already given to you, that is 0.083. So 0.083. Okay, when you will solve this whole value, okay, yeah, so you just have to multiply, solve, you have to convert ln into logarithmic. Here you will get the temperature value. Okay, so it will be approximately, multiplying it and solving this, you are going to get the value around 1120. So this is going to be the value of temperature during this particular process. So the work done will be given by, you just have to substitute everything over here in the formula of work done. So let me do that. So minus number of moles is 1. Okay, R value I have to take 0.083, temperature is 1120. Alright, then I will be having ln 92.96 divided by 46.48. So when you cancel out these things, you will get 2 here. So what you will get is minus 0.083 multiplied by 1120 and multiplied by ln 2. Okay, this is what you will get as WBC. So I'm just writing it over here. So we calculated the work in the two different processes, in AB and in BC. Next is we have to calculate the work for the CD process. So I'll do that in the next slide because I don't have space over here on the screen. Okay, looking at the process C to D, over here again you can see that again this process is isobaric, and because the pressure is constant over here, and this is now going to be a compression. Okay, so it's isobaric compression, that's what is going to happen. So let's do it. So like your process, that is CD, is what is isobaric compression. Okay, that's what the process is. Now WCD will be given by again minus P delta V. So the pressure at point at for this particular like between C and D is 1 bar. So we'll put minus, and 1 multiplied by delta V is 92.96 and minus 92.96, and it is 23.24. So 23.24. So just subtract it, and here you are going to get the like the work done in this particular process. Talking about the last process, that is DA. So if you talk about the process DA over here, you can see that the volume is fixed, right? It's an isochoric process because the volume is fixed over here. There is no change in volume. So this process is isochoric, and you know that the work done in isochoric process is 0, right? So that means what, that is W dA is actually equal to 0. Why? Because it is isochoric process. Okay, so it's isochoric process. So what you have to do now is you have to just find out W total. So I have calculated all the values on my rough notebook, and it will be WAB plus WBC plus W CD plus WDA. So all the values I have already given to you. You just have to do little calculation, and when you put over there and solve it, you are going to get minus 41.8. um, this is what you are going to get in liters bar per Kelvin mole. Okay, that's what you are going to get. So basically you can write down this everything is in kilo, like this everything whatever you have got is in this particular unit. You have to convert that into joules. So I guess in the question we have that to how to convert that. So liter bar, you can convert that into joules by multiplying it with 100. Okay, so liter bar is the unit which we have, so we can convert that into joules per Kelvin mole. So by that we can, like, in order to convert that, we just have to multiply it by 100. Okay, so minus 41.8, and you can multiply by 100 to convert this into joules. So the answer will be how much? This will be minus 4180 joules. This is going to be the answer for this particular question. Okay, so if you look upon the options, so the correct option will be option number 2. So the answer is quite near to that. So that's why the correct answer is option number 2. So it was very like calculation specific question where a lot of calculation has to be done, and you have to be very specific with the formula, with the diagram, with understanding the curves, and in order to calculate and then do the question. Okay, so we have to do a lot of stuffs to find out the answer exactly. So these kind of questions are said to be calculation specific. So that's what it is. All right, let's move on to the next question then. Alright, let's talk about this particular question over here. It says that the Huckel molecular orbital of benzene, that is degenerate with the molecular orbital. Okay, this is the molecular orbital given to you, and it is asked that which of these molecular orbital are going to be degenerate with it. So degenerate means what? It means that they have equivalent amount of energy. Okay, both of them have same energy. And for the molecular orbitals, we understand the energy values through the number of nodes. Okay, once you get the number of nodes, so two energy levels having same number of nodes, or two orbitals having same number of nodes, will have equal energies. So this is one thing which you should know. Now next thing is how to find out the number of nodes for this particular molecular orbital. Now this is the orbital given to you. So you know that benzene you have, right? So benzene will have 6 carbons. So you should have six values of chi. Basically chi 1 and chi 4, which are missing over here, they should also have been. But that is the case when you have node on a particular wave function. For example, let me just show you one example of it. So for a three like for a allylic carbocation or carbon ion, or for free radical, your nodes or the wave functions are made like this, right? So like this is the lowest energy wave function. Then you have, so for this there will be zero number of nodes, so shaded lines will be on the same side. The other node, like the other energy level, goes like this. Okay, so you have a dot over here. So this dot means what? That the node falls on this particular orbital. So that's why this orbital is missing from this wave function. So this will be your chi1, sorry, psi1, this will be psi2, and your psi3 will be like where you will be having two nodes. Those will fall in between of them. So they will be like this. Okay, so I have given this example just to show you. So this is psi3, just to show you that how and when these orbitals will be missing from the wave function. So when they are missing, that means the node is falling on them also. Okay, so now the given wave function is what? It is 1 by 2, and you have chi 2 plus chi 3 minus chi 5 and minus chi 6. Now what you can see over here is which are missing. So basically if I write down like this: chi 1, chi 2, chi 3, chi 4, chi 5 and chi 6 all. So this is missing, so this will be one node. Okay, this will be the first node. Okay, I'm just encircling them. So circle means their node will be there. Now the sign is plus over here for chi 2. For chi 3 also sign is plus. Now chi 4 is also missing, so let's remove that. I'm circling, that means this is the second node. And after the node the sign will change, right? So that's why it is negative in sign, this is negative in sign. So that means what? How many nodes are there? So number of nodes in the given wave function is 2. Okay, there are two nodes over here. many people didn't understood it in that way, and they just saw that okay, there is only once when the sign is changing, so they thought that okay, number of nodes is just one. But here you have to analyze it in this way. Okay, so there are two number of nodes. Now you have to find out in the given options that where you have two nodes. Okay, so let's talk about option number one. So here the sign changes once over here, and once over here also. Okay, and you have all the functions like chi1, chi2, chi3, chi4, chi5 and chi6, all of them are there. And how many nodes do I have? So one node, because the sign changes here, and the other node, so two nodes. Two nodes is what you got over here. If you look upon option number 2 here, so how many nodes you have? So you will have, again, see, chi1 and chi4 are missing, and apart from that the sign also changes at this particular place, and at this particular place, and at this particular place. So 3 and 2 are missing, so total sorry, 4 nodes will be there. Okay, there will be 4 nodes, because one will be at chi1, the other one will be because of the sign change, the other one will be at chi4, then the chi5 obviously sign will change because there is node at chi4, and then the sign is changing at chi6. So 4 nodes will be there total. Okay, here if you look upon option number 3, so the sign changes once over here because it is changing from plus to minus. Secondly, it changes from here from because it is changing from minus to plus, and thirdly it is changing over here. So you got 3 nodes in this particular case. And in the last one, if you see, so the sign changes once here, twice here, thrice here, 4 times and 5 times. So you got 5 nodes in this case. So the only option which matches with the 2 nodes is your option number 1, and that is going to be the correct answer. That is going to be the degenerate energy level, or the correct answer for the given particular question. Okay, so degenerate means the one having similar energy, and energy is calculated based upon the number of nodes. So that's how the answer will be option number 1. Alright, I hope this is much clear to you. If you have any doubt with this, you can ask in the comment sections. Okay, let's move on to the next question. The next question says that the reaction is given to you, that is K is reacting, the potassium is reacting with bromine, and it's giving you KBr plus Br, which follows the harpoon mechanism. Okay, so it's following the harpoon mechanism. The reactive cross section is closest to, so you have to tell what is the reactive cross section will be equal to. Okay, now we have to discuss few things. First of all, harpoon mechanism, and the next thing which is being asked. Okay, now here harpoon basically means it's a word which describes a pin which is used for fishing. Okay, it looks something like this. So it looks something like this. So it's kind of like the mechanism which we show for like the arrows which we show for free radical mechanisms, right? So this is how the harpoon looks like. So basically what they are trying to say is the reaction is going something like this, that is your K is reacting with Br2 in such a way, okay, using this harpoon mechanism, and then you are getting KBr and a Br radical. Okay, so that's what the reaction is. Now what they have said is okay, so basically you have two things in this particular reaction. First of all, you are preparing like potassium is in the atomic form. You are preparing the ionic form of that, and then you are reacting with, or basically you are removing one electron from this potassium. Okay, then only it is going to react with your bromine. So that means you are undergoing two things over here. First is you are you have to overcome the ionization enthalpy, and the second thing is you have to overcome the electron affinity. So the difference of both of them will be equal to the total energy which is required for the removal of electrons. So that will be given by E square upon 4 pi square, sorry, E square upon 4 pi epsilon naught R. Okay, that's what it will be. This is overall equal to the electric field, like the energy which is required. Now over here this R is nothing but the radius of reactive cross section. Okay, so R is what? It is radius of reactive cross section. Reactive cross section. Now this question you can only do if you remember, if you know this formula. Many students were not aware about it, so that's why they just left this question. But yeah, it was just directly based upon this particular formula. So let's try to do fine. So it will be like r will be actually equal to, then so r will be equal to E square upon 4 pi epsilon naught, and this will be equal to yeah, so we have taken r to that side, and I will have ionization energy minus electron affinity. All right, now you know one thing, that this difference of both of them is actually given to you, that is the difference of ionization energy and the electron affinity is actually given to you. Okay, so the ionization energy of potassium is given to us as 422.5 kilojoules, and electron affinity is also given to us for Br2, that is 250 kilojoules per mole. So that's what you have to do. Now one more thing is that if you look upon the values, all these values are given in per moles. Okay, they are given in per moles, but here you are not considering the mole factors. So in order to convert this per mole into the total energy, you have to multiply with the Avogadro number. Okay, so you have to multiply with the Avogadro number, so that's why I have multiplied with Na. Now I'll substitute the values over here. So R will be, now the value of this whole thing is already given to me in the question, in the hint form. That will be 2.3 into 10 to the power minus 28, and remember this is in joules per meter. Okay, then Avogadro number will be 6.022 into 10 to the power 23 divided by, I just have this term in my denominator, so this term is ionization energy, that is 422.5, and minus electron affinity, that is 250. Now remember one thing, that these terms are in kilojoules. These two things are in kilojoules, whereas this term is in joules. So I have to convert this as well into joules. So I have to multiply with 10 to the power 3 to get converted into joules. Now this is what you have, complete numerical values. You just have to multiply, solve the powers, and you just can get the value at the end. Okay, so the value which you will get will be approximately equal to 8 into 10 to the power minus 10 meters. Okay, so that's what you are going to get as the final value of your R. Now R is the radius, but what they are asking is the cross section area. Okay, so the cross section is what they are asking. So the cross section will be taken as a circular section, and that will be taken as pi r square. So put the value of pi, that is 3.14 multiplied by 8 into 10 to the power minus 10 ka whole square. So if you multiply and solve this, you are going to get this as 2 into 10 to the power minus 18 meter square. So the correct answer will be your option number 2. So that's how it has to be done. It is just based upon the mechanism. You should know that what is happening. So potassium will react with bromine. So in order to break this, because bromine is accepting electron, so electron affinity of bromine is used. Potassium is giving electron, so ionization energy of potassium will be used. So that's why ionization energy minus electron affinity, that is going to be the total energy required for the reaction, and that will be equal to E square upon 4 pi epsilon naught R. So we have just substituted the values, calculated the value of R, then put it in the cross section formula to get the final answer. So this is how we have to solve this question. This was a little bit, I would say that this was difficult for those who don't know the formula, but for those who know it, they might have done this question very easily. And one more thing, that this was also a numerical specific or calculation specific kind of question. Okay, all right, let's move on to the next question then. The next question over here, it says that the pure rotational microwave spectrum of XY molecule, the adjacent lines are separated by 4 centimeter inverse. Okay, so two things which are given to you right now is the pure rotational microwave spectrum, okay, of a molecule, and the adjacent lines are separated by 4 centimeter inverse. So in the pure rotational microwave spectrum, in pure rotational microwave spectrum, what happens over there, that you have lines, let's say. Okay, you have lines, and the difference between two adjacent lines is actually given by 2b, right, where b is your rotational constant. So that means what, that 2b is equals to 4 centimeter inverse. So what is going to be the value of b? B will be equal to 2 centimeter inverse. So we have calculated the value of b. That's the first thing which we have done. Now the second part of the question says that if the molecule is irradiated by radiation of this much, that is 30,000 centimeter inverse, the first Stokes line appears at. So Stokes line, we will obviously we will get it in Raman spectroscopy, right? So we'll get it in Raman spectroscopy. But here, since you are doing rotational and Raman, so this question is basically from your rotational Raman spectroscopy. Okay. Now in the rotational Raman spectroscopy, you should know one more thing, that rotational Raman spectroscopy, you have a Rayleigh line. Okay, you will get a straight Rayleigh line. So this Rayleigh line has the maximum intensity, and it is only like it is that particular frequency at which you are radiating or you are exciting the molecule. So this is nothing but excitation frequency. Okay, and then you have a Stokes line and anti-Stokes line. So we know that the difference between two Stokes line is 4b over here, and between two anti-Stokes line, that is also 4b over here. Okay, so the distances is 4b and 4b. So let me just write down. So the distance will be 4b over here. Okay, and these are your Stokes line, and these are anti-Stokes line or anti-Stokes line. Okay, these are also separated by 4b distance. And if I talk about the first Stokes line, okay, so that is actually at a distance of 6b from your Rayleigh line. Similarly, anti-Stokes line is also at a distance of 6b from the Rayleigh line. So if you calculate this particular question, for this, you know the Rayleigh line is over here, you calculated the value of b. Now they have asked the first Stokes line, where it will be. So the distance of first Stokes line will be how much? So distance of first Stokes line, okay, Stokes line, it will be 6b, right? 6b means 6 into 2 centimeter inverse, that means 12 centimeter inverse. Now obviously this is Stokes line are taken to the left side of your excitation frequency. So if this is 30,000 centimeter inverse, so this first Stokes line will be lesser than that, right? So first Stokes line will be equal to, like, at what value they will be? So at 30,000 minus 12, you have to subtract this value over here. So you are going to get 29,988 centimeter inverse. So this is going to be the position of the first Stokes line. Similarly, if anti-Stokes was asked, so the answer would have been 30,012, because that will be on the right side. So you have to add that 12 over here. Okay, so that's how we have to do this question. Okay, so the correct answer will be option number 1. Alright, I hope this is much clear to you. Let's move on to the next question then. Okay, the next question, which is asked on the Debye length, and the question says that the electrolytic solution of the smallest Debye length, okay, smallest Debye length is being asked for at 298 Kelvin. So let's try to do this particular question. So your Debye length, what it actually is. So Debye length is nothing but it's the average length. Okay, it's the average length up to which the charge will be screened, okay, upon solvation, up to which the charge will be screened, okay, screened upon solvation. So this is the definition of your Debye length. It is given by lambda d, and you might have seen in many books it's given like lambda d is equals to 1 upon kappa. And if you look upon the formula, you don't have to remember the complete formula, but if you look upon that, you will find out that it is inversely proportional to under root of I, okay, where I is your ionic strength. Okay, so that means what we can say, that for smallest, because it is asked about the smallest, so for smallest lambda d, our I should be highest, okay, because they are inversely proportional, highest. So for highest I value, the formula goes like this. The I is given by this formula, that is half sigma Ci Zi square, where C is the concentration and Z is the charge. Now if you look upon, so that means what, that the concentration should be more and the charge should also be more, the overall charge should be more. If you talk about all of these options, the concentration is same in all of them. So that means what, you just have to look upon the charge. Okay, so for the first one, I'll just write down, so it's +1 and -1. So this is the charge values. Here you have +2 and +2, so this is again going to be the charge value over here. Sorry, +1 and +2, because sodium will have +1, right? So overall you will be having +2, so overall you have 3. The charge is 3 over here, right? The charge is 2 over here. Over here if you look upon, so copper will have +2 charge and chlorine will have -1. So again overall charge is again 3, right? So don't think like it is plus and minus, so why I am not adding and subtracting. The overall charge is taken in modulus because that's going to be squared up, so that's why I'm saying. Okay, if you put it over here, from the first one it will be 1 square plus 1 square, so you will get 2. Here 1 square plus 2 square, you will get 5. Here 2 square plus 1 square, again you will get 5. Here what you are going to get, it will be +3, because lanthanum is a like lanthanum has a +3 charge and chlorine will have -1 charge. Okay, so here you will get 9 plus 1 10. So highest value for the charge is going to be for option number 4. So since the concentration is same, so the highest charge will be here, and if the highest charge is here, so Debye length will be smallest. So the smallest Debye length will be for this, for LaCl3. That's how you can easily predict. Or if the question would have been asked based upon the highest Debye length or the largest or the longest Debye length, for that you have to look upon the smallest charge. Okay, so for that answer would have been option number 1. Okay, I hope this is now clear to you. Let's go to the next question then. Okay, the next question, which is pretty direct one, it is based upon the question which we have already done in the thermodynamic series. So I'm not going to solve it over here further, but yeah, it says that Cp minus Cv for non-ideal gas differs from Cp minus Cv for perfect gas by the expressions. What is the expression for Cp minus Cv for a non-ideal gas? So if you solve that particular equation for Cp minus Cv for real gas, you will find out that option number C will be the correct option. Okay, this I have done, I have solved it many times in my in the previous like in a course which is going on, basically a series of videos which is going on the channel on thermodynamics. So you'll find out the complete derivation over there, so I'm not going to derive it here, right? So option 3 is the correct option. Let's go to the next question, where it says that the trans 1,2-dichloroethylene, the IR inactive mode. Okay, so trans 1,2-dichloroethylene, let's make that. So 1,2-dichloroethylene will be this, and you have a trans molecule. So this particular molecule is the one which is given to you. Now first thing which you should understand over here is this molecule has an inversion center, okay, or center of inversion. That means this particular molecule will follow rule of mutual exclusion. Okay, what does this rule says? This rule says that if any IR mode will, any vibrational mode, if it will be IR active, it will be Raman inactive, and if it will be Raman active, it will be IR inactive. Okay, so you have to find out all the possible vibrational modes which are given to us. Let's look upon them one by one. So the first one which says CCl symmetric stretch. Okay, so carbon and chlorine symmetric stretching. So if I do symmetric stretching to these bonds, what I will get something like this. Okay, this is what I will be getting. So here if you look upon the molecule, what is going to happen over here? Is the dipole moment, what is going to happen to the overall dipole moment? So the overall dipole moment will be equal to 0, because the dipole moment of these two bonds are going to cancel out each other, right? So overall dipole moment will be 0, and that's why the molecule will become IR inactive. Okay, so that's correct. The first one is only correct. Let's look upon the other options as well. Other one says that CCl asymmetric stretching. Asymmetric means I am pushing this particular bond and I am stretching this particular bond. So that means what kind of structure I am going to get now? So I'll be having this bond longer and this bond will be shorter. Okay, this is how I am going to get. So here I will be having certain value of dipole moment. So the dipole moment will not be equal to 0. And if there is some dipole moment, that molecule will be IR active. Okay, so this will be IR active. Next, again, a CH asymmetric stretching. So similar thing is going to happen with carbon and hydrogen. Okay, now your carbon, one of the hydrogen will have a longer bond. So here you have to look upon this. So one of the hydrogen bond will be longer and the other one will be shorter. So again, the same thing is going to happen. So this will again be IR active. Similarly, the last one says, in which it says in phase out of plane carbon chlorine bending. So you are bending the bond. Okay, so in phase out means one chlorine you are taking out of the plane, and the other one you are pushing inside the plane. So overall, what you are doing, what you are going to do is that you are changing the dipole moment of the molecule, right? Because the molecule will no longer become planar to each other. So that means what? That there will be some change in the dipole moment. So it is again going to be IR active. So the only mode which is not going to be like where you will not get any overall dipole moment is the symmetric stretching. Okay, when you are doing symmetric stretching. So this is going to be IR inactive. So answer will be your option number 1. Alright, let's look upon the next question then. Alright, so let's talk about this particular question over here. It says that the order of surface catalyzed unimolecular reaction at very low and very high pressure of the reactant would be. Okay, so now this particular question you can do like first of all let's try to understand that it's the surface catalyzed reaction mechanism, where this is the surface which will behave as a adsorbent, and you have adsorbate which is unimolecular, so it's not interacting with each other and it is actually like it is getting adsorbed on the surface. So if you are reacting this like if R is the reactant and if M is the metal surface on which the reaction is happening, then in that case you will have a complex which will be formed in the first step, and in the next step this particular complex will undergo dissociation to give you product. Okay, so that's what the reaction is this reaction is all about. Now this reaction you can even do based like from your according to your Langmuir adsorption isotherm. So the Langmuir adsorption isotherm says that theta is equals to Kp divided by 1 plus Kp. Okay, where K is your equilibrium constant, P is the pressure of the reactant side, and theta is the surface which is being covered by the adsorbate. Right now, this particular theta for the surface catalyzed reaction can also behave as rate. So you can say that rate is actually equal to Kp divided by 1 plus Kp. Now you have to deal with the pressures now. So what is going to happen at low pressure? Okay, at low pressure, your Kp will be like P will be very much smaller. So 1 plus Kp, you can take it as 1. Okay, so your rate will be equal to only Kp. So at low pressure, the order is actually going to be first order. Okay, so at low pressure you are getting first order reaction. And what is going to happen at high pressure? So at high pressure, if you see, so your Kp will be greater than 1. So you can put Kp over here. So your rate will be equal to your Kp upon Kp. So this is going to be 1 or it's going to be constant. So the order will be equal to 0. So that means what? That at very low pressure it's a first order reaction, at high pressure it's of 0 order reaction. So the correct answer will be option number 2. So that's how simply you can take this like you can understand this reaction mechanism, and you can just do it in this way. Alright, let's move on. And there is one more way to solve this question. Let me just tell you that is by using by considering this particular reaction as an enzyme catalyzed reaction and using Michaelis-Menten equation for that. Okay, although it's not enzyme catalyzed, but it's quite similar to that, right? In that also you have enzyme plus substrate reacting to give you enzyme substrate complex, and that complex is giving you product. So it's quite similar to that. So you can use even that process also, and that equation also in order to get your enzyme, like in order to get Michaelis-Menten kind of equation, and over there that particular equation you can use to solve it further. So there also you'll get the similar results. Okay, I have done it using Langmuir adsorption isotherm. You can use that Michaelis-Menten equation as well. Okay, let's go to the next question then. This is going to be the last question of the video. It says that in linear variation method using two orthogonal basis function, the two roots obtained were epsilon naught and epsilon 1, where epsilon naught is smaller than epsilon 1. The correct relation of these with exact ground and first state energies E naught and E1 respectively is. Okay, so you have to tell about the exact relationship between, like the relationship between the exact ground state energy and the exact first state energy. So to do this particular thing, first of all, it is basically from your variational theorem. Okay, variational theorem. So we will use that variational theorem, concepts of variational theorem to solve this question. Alright, so according to this variational theorem, we know one thing, that energy of the trial wave function, okay, energy of your trial wave function is always greater than or equal to your energy of the exact energy. Okay, that means it is always greater than or equal to the exact energy. So this is what we know. This is something which is very basic from your variational theorem. Now it is given that your two values, which are given as epsilon naught and epsilon 1, these are actually obtained by linear variation basis function. Okay, and so these are obtained by linear variation basis function. Okay, variation basis functions. And it is also given that orthogonal basis is given over here, right? That these are orthogonal, two orthogonal basis functions are taken. So orthogonal basis means they cannot be degenerate. Okay, they are not degenerate. Okay, so that's what it means. So that means they will not have same energy. Okay, so orthogonal basis means what? That they are non degenerate and they belong to the successive energy levels. That's what it means. So orthogonal basis means the lower one is epsilon naught and the higher one is epsilon 1. That's what it means. Okay, so epsilon 1 will be of the higher energy and epsilon naught will be lower energy. And if I talk, these are linear, like these are obtained by the linear variation method, and the exact energy is the ground state energy is E naught and the higher energy is your E1, right? Now what will be the relationship between both of them? Obviously your epsilon naught will be greater than or equal to your E naught, right? And the other part, which is your epsilon 1, will be greater than or equal to E1. Why? Because this is actually corresponding to, the epsilon naught is corresponding to the ground state energy and epsilon 1 is corresponding to the first excited state energy. So they have not mentioned directly, but yet based upon these terms, which is orthogonal basis function, you can understand that they are non-degenerate and they belong to successive energy levels. So the lower one will be epsilon naught, the higher one will be this. Based upon that, you can say that option number 4 is your correct option for this particular question. Alright, so we have done all the questions up till now. 10 questions were done in the previous video, where in the part 1 video. If you have not yet watched that, I'll be giving you that link of that particular video over here. You can just click on that I button and watch that particular part as well. So 10 physical chemistry questions were done in that particular part. 10 are done in this particular part. So all of your physical chemistry portion has been completely clearly solved in all the, like, which were asked in the on 15th of December 2019 exam. There are many questions to be solved yet. Your inorganic questions are yet to be solved. Your Assam and Meghalaya region question paper is yet to be solved. So I'll try to solve it as soon as possible and I'll try to update it on the channel. So if you are new to this channel, if you have not subscribed it yet, do subscribe to the channel. And if you like this video, give it a like. And thank you so much for watching. And that's all from my side. Thank you so much for watching, guys. Have a great day. Bye bye.